a hash function, and the output, okay, usually is called the hash of the input, or some people call it the fingerprint of the input data. Okay, this is one property. Okay, the second property is what we call one-way function, and this is one of the very, very crucial property of hash function, and make it very right. This is so important in application in, say, blockchain. Okay, is this idea that's made it very hard to back calculate the what do I mean by that? There's some kind of one way. Okay, going one way is easy. Just like when I talk about the key pair, going one way, going like multiplying numbers is easy, factorize is difficult. Similar kind of principle. Let's say I have the input, the catch element. So if I give you this, it can run the function. The function is on the I mean, it's open source. I mean, anyone can use the function. Okay. So if I give you the input, you can very easily run the function. Very. That's a very efficient algorithm that gives you the output. Okay. But let's look at the bottom, which is now I slightly changed the input slightly. Okay. I only changed the last character of the sentence. Okay. Which from the T to the N, and you notice that the output there's no resemblance. Okay, even though the input are very, very close to each other, the output is very totally different. And look at no relationship at all. Okay, and precisely because of these, it makes it very difficult to go back. Meaning that if I give you the input, I can easily calculate output. But if we just give you a thing on the right-hand side, just some random string, and ask you, okay, can you tell me which input when you hash will give me this thing you show me? And that's very difficult. Okay, so going one way is easy. If I give you some random string, okay, and then tell you where it come from, what is it, hash of what, and then ask you, can you tell me which thing you hash will give me this string? That's almost impossible. Okay, this is the one-way function. And the second is that it is hard to find something called collision. Okay, it's hard to find two input to hash the same input. And if you can find two input that hash if you can find two input that can hash the same output, that's called collision. Now, of course, because the output, okay, the length is fixed, right? Whereas the input, the size can be arbitrary. So that means the size of the input is much bigger than the size of the output. So because of that, there must be collision, right? Just the fact that the input is much bigger than the output. So you know that there must be collision no matter what kind of hash function you have, okay? But when you say collision resistant is that, yes, I know that there are, but it's impossible to find out, to able to come up with the collision. Okay, for example, the SHA-256 that blockchain people use, I mean, right now, I don't think anyone can able to find any kind of collision. Okay, and that's because the combination of the output, okay, which is the 256-bit, is like, if this binary is like 2 to the power 256, then it's a huge number, and then you try brute force and find collision, it's impossible. And then also the other property is what we call hiding, meaning that again, if you know the hash, you're not able to infer anything about the input. Like for example, what length of the input size is, whether it's an even number or number or whatever. So it's again, so this is called hiding, because this is the property of a hash function. Okay, so. Another thing is about how the computational wise, again, you're given an input x, it's easy to compute h, okay? But if I given something y, which I know cover of h of x, but if I don't tell you what x is and ask you to tell me what x, okay, such that h of x is y, that's impossible. Okay, that's the one-way property. Okay. So these are all the key property of a hash function. Okay, let's look at what hash function are used in blockchain.